AI. It's a term that's just everywhere, right? But what it really means, its capabilities, what it's actually aiming for, that often feels, well, a bit murky.
Yeah, definitely. Are we talking thinking machines like in the movies or something? Well, something else.
Exactly. So today we're going to try and cut through some of that buzz, give you a clear picture.
Right. Our mission, you could say, for this deep dive is to unpack what artificial intelligence actually is. What are its big goals? And crucially, what are the differences between the powerful AI we use every day and that more elusive idea of artificial general intelligence? That's been the dream for a long time.
And we've looked at quite a range of sources for this.
Oh, yeah, a fantastic collection, foundational texts, interviews with some of the key people who actually built the stuff. We've tried to pull out the really important insights for you.
Okay, so let's start at the beginning. Artificial intelligence. What's the core idea, the big picture goal?
Well, at its heart, AI is simply about machines showing intelligence. But the really ambitious goal, at least according to some of the pioneers, was always, to quote one source, replicate in machine substrates the general purpose learning ability and planning ability that makes us humans smart.
Wow, okay, so not just mimicking tasks, but replicating intelligence itself.
Pretty much. The idea being if you can solve intelligence, maybe you can then solve, well, everything else.
And a huge part of modern AI, the engine driving it, is machine learning. How does that differ from, traditional programming?
Good question. Machine learning is key. It's a branch of AI where algorithms basically program themselves. They learn from data.
So it completely flips that old idea that computers only do what you explicitly tell them to?
Exactly. That was a huge shift. And within ML, you have deep learning using these complex, layered neural networks, kind of inspired by the brain, which has been behind a lot of the recent really impressive breakthroughs.
That vision of solving intelligence is huge. But let's talk about right now, what does AI actually look like in the world today? Are we dealing with those thinking machines, or is it more specialized?
It's overwhelmingly the second one. What we have, for the most part, is narrow AI.
Narrow AI,
Meaning it's very task-specific. It gets incredibly good, maybe even superhuman at single functions. Things like pattern recognition using labeled data.
So that's the tech behind things like facial recognition or translating languages.
Precisely. Or even systems like AlphaGo that beat world champions at incredibly complex games like Go. Really impressive stuff, but narrow.
Okay, so incredibly powerful in its lane. But does that narrowness, that task-specific nature, mean there are fundamental limits, even if you had infinite data?
That's a really sharp point. Yes.
Yeah,
The sheer amount of data these narrow AI systems need isn't just a practical hurdle, it hints at something deeper.
So,
Well, they get their power by crunching massive quantities of human-labeled data. As one expert put it, this data requirement is a major limitation. I mean, think about it. We can't possibly label everything in the world.
right, you can't sit down and explain every single detail of reality to a computer.
Exactly. And that leads to significant blind spots, even in areas where they seem amazing.
What kind of blind spots?
Well, despite that superhuman performance in their specific task, current AI really struggles with things humans find easy, like abstraction, taking a concept and applying it elsewhere, or domain generalization.
Meaning they don't transfer learning well.
Not really, no. They can overfit to their training data. They get too good at the specific examples they were shown, but then fail unexpectedly when faced with something just slightly different.
Is that where things like adversarial attacks come in? Where tiny changes fool the AI?
Absolutely. You can make almost imperceptible changes to an image, say, and the AI suddenly misclassifies it completely. It shows a kind of brittleness.
Right.
And with language, they often miss subtlety, purpose, common sense reasoning. They don't understand in the human sense.
This contrast really brings us to that big dream you mentioned, artificial general intelligence, AGI, the true thinking machine.
Right. AGI, sometimes called human-level AI or strong AI. It's the idea of a machine that can understand context, that has situational awareness, can reason in nuanced ways, and maybe most importantly, can learn effectively from much, much less data.
Like the classic sci-fi examples, HAL 9000 or data from Star Trek.
Exactly, those kinds of concepts, though hopefully less prone to malfunction.
A lot of people probably think of the Turing test here. Alan Turing's idea from 1950, if a machine can fool you into thinking it's human in conversation, it's intelligent. But
Right.
is it that simple?
Well, it's a fascinating benchmark, but Yeah, it raises questions. We've seen chatbots, like one called Eugene Goostman, fool some judges for a short time by pretending to be, say, a non-native speaking teenager.
So tricking someone doesn't necessarily equal deep understanding or real intelligence?
Probably not. And this feeds into the huge debate. Is AGI close? Or still science fiction? Predictions are, frankly, all over the map. Some say maybe 2029, others say more like 180 years, or even
A
longer.
huge range.
A huge range. And many serious experts argue we've made almost no progress on strong AI, on general intelligence. They see deep learning as powerful, yes, but just one tool in the toolbox. It hasn't solved fundamental problems like reasoning, background knowledge, common sense.
Which leads to some pretty deep philosophical worries too, right? I read some thinkers are genuinely terrified.
Yes, terrified that qualities we think of as uniquely human creativity, consciousness might turn out to be, quote, disappointingly simple to mechanize, that maybe our deepest values could be reduced to just a clever bag of tricks.
It's a sobering thought. So let's try and wrap this up. We've looked at what AI fundamentally is, this big goal of replicating intelligence. We've distinguished the narrow AI we have now, powerful but limited, data-hungry, from the dream of AGI.
Right, that distinction is key. Narrow AI is amazing at specific tasks, but it's not thinking in the way we usually mean it. AGI remains this profound, maybe distant challenge.
So here's something to chew on. Think about the gap between what even the most advanced narrow AI today can do and what a young child learns so effortlessly. Things like common sense, understanding context, learning abstract ideas from just one or two examples, not millions. What does that huge difference tell us about intelligence itself? Are there aspects of it, maybe uniquely human aspects, that might just always be beyond what machines can replicate?